T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4. Go for main engine start. 3, 2, 1, 0. And ignition and liftoff of the Atlas V with the Solar Dynamics Observatory, learning why our star is changing our lives.
Missions at NASA are built in several phases. The phase that we're in is the build and launch phase, where we put everything together, we test it to make sure it works, stick it up on top of a rocket, and launch it into space. Once it's in space, then we test it out again.
During the 5 or 6 years that we're building a mission, building the hardware, designing, testing, we're on the ground. And this isn't where the observatory lives. It lives in space. So that's what the commissioning phase is. We're in our home environment now, where SDO is going to live for 5 or 10 years. And we want to make sure that everything works as we designed it to work. So that's intense, in SDO's case, 2-month phase of testing out all the aspects of the observatory and the instruments to make sure that they work as designed.
The testing phase, the commissioning phase, is extremely important to the science phase, because that's how we understand how the instruments operate. We don't have to produce science data, but we do have to create an understanding of the instrument so we can produce better science data.
In the case of SDO, our commissioning phase was very smooth. So because we, the engineering side and the scientists, did our job so well during design, build, and test, we had a smooth commissioning, and SDO is performing wonderfully.
The project during build and launch has been controlled by Liz Citron, our project manager, and she's had to worry about budget and schedule and making sure everything showed up on time. Building a satellite's like a big just-in-time assembly line, where things are being put on the spacecraft and they have to be put on in a certain order, and you want everything to show up at the right time to be put on the spacecraft. And they've done a great job. The engineers here at Goddard have done a marvelous job of getting the spacecraft assembled, tested, and launched. And now it's time for some scientists to turn up and start running the spacecraft to take data.
The handover is when you're done building and testing your mission, and you start an operational phase, and the scientists start doing their thing, and the engineers who built the observatory, who built the instruments, are really backing away and going on to build other missions.
Handover is a kind of a strange thing at NASA. You take it from one group and give it to another, but it does symbolize an end to some people's participation in the project. Liz did a very nice job of working with her team and keeping the team excited about building this observatory. And I think that shows in the pride that people have taken in their work and how happy they are that we're getting good data back.
You know, it's the next phase in the life of SDO, and in my life too, because I'll move on to the next thing, and in the engineers' lives. You know, it's just what we go through, but it's different than most people's careers, because we have you know, a defined project, about 5 years. We know it's going to end. It ends, and we move on. So it's exciting, but it's a little bit sad. It's your baby, and you have to, you know, let it go. Go do its thing.